Okay, here we go with the R alpha method. Okay, when you've built up some experience in this, you kind of know that R is going to be the Pythagoras of 3 and 5. In other words, it's going to be the square root of 3 squared plus 5 squared. And you know that tan of this alpha is going to be either 3/5 or 5/3 or related to that tangent. And it is okay to really learn your stuff and just announce your R and your alpha using those. But I think you should be able to get this from first principles by expanding this, doing some comparing coefficients, and you can reduce the amount of working you show later if you choose to do that. So we're going to start with 3 sine x plus 5 cos of x. Okay, and that's got to equal r sine x plus alpha, but I am going to expand this. So I've got an r in each term, and sine of a plus b is sine a cos b plus cos a sine b. So it's r times sine of x times cos of alpha, and the other term is also going to have an r because I'm multiplying through by that, and it's going to be cos of x times sine of alpha. So now I've got to match up things from the two sides. And essentially it's a comparing coefficients type argument. This has got to be true for all values of x. Okay. If I look for the x's, I've got a sine x over here and I've got a sine x term over here. Okay. And likewise, I've got a cos x term over here and I've got a cos x term over here. Now, if I look at the thing that's with the sine x, which is r cos alpha, if I take my r cos alpha and say that that has got to be the same as 3, and simultaneously the cos x term is going to match as well, so the 5 I've got on this side is going to be obtained with the r sine of alpha. If I did make both of these things be true, then this line would have to be true, because the r sine alpha would give me the 5 that I need, and the r cos alpha would give me the 3 that I need. So if I can find an r and an alpha that make this true, then I'll be okay. So how do I find r and how do I find alpha? Well, let's start with r. That's actually requires a slightly fancier method starting from these equations here. But the idea we're going to use is that cos squared alpha plus sine squared alpha is 1. So if I square both of these, I'll get r squared cos squared alpha, and I'll get r squared sine squared alpha. And the answers to those will be 9 and 25. Okay, so if I add the two together, then here I'm going to clearly get 25 plus 9, which is 34. And here I'm going to get r squared times cos squared alpha plus sine squared alpha. But this bracket of cos squared alpha plus sine squared alpha is 1. So r squared is 34. Therefore, r equals the square root of 34. Okay? Now, that's going back to how I use this identity from first principles to work out that these two statements lead to this. When you've got the experience, okay, it is okay. It's perfectly fine to say, I know from experience that the way I dig r out of these is I say that r is going to be the square root of the 3 squared plus the 5 squared, okay, which is the square root of 34. Now, I hope you're thinking, he didn't put plus or minus in front of the square root, okay, and in the first instance, it's not a bad thing to at all, but we are always, or nearly always, we're given this provision that we've got to make r be positive. I could make this work with a negative r. I've always got a choice, in fact. I can have a positive value of r, and there'll be a value of alpha which would make that work, and I can have a negative value of r. If I choose r to be positive, the question is guaranteeing that I can get away with an acute angle for alpha. So that's kind of the question, and I'm definitely going to do what it tells me to. So I want plus the square root of 34, and I'm going to go on and find alpha, and it's clear that I can eliminate r here by doing a division. If I do r sine alpha and r cos alpha, if I divide them, so if I do r sine alpha over r cos alpha, then on the one hand the r's cancel and sine alpha over cos alpha is tan alpha, okay? But on the other hand, I can say that r sine alpha is 5, so I have a 5 on the top, and r cos alpha on the bottom is going to be 3. So tan of alpha is 5 over 3. So my first alpha would be arctan of 5 over 3, okay, and I'd have a second alpha normally, but I'm guaranteed that alpha is acute. Okay, so the arctan of 5/3 is my acute answer. So I don't need to consider the second alpha in this case, because the first alpha is the alpha in the set of values that's specified. So after double checking that I'm in radian mode, I can do the inverse tan of 5/3, and I get that many radians, which is going to be my answer. So I have my r and I have my alpha, but it says express it in this form, so I should write it out. In fact, let's be proper, let's write out the left hand side as well. 3 sine x plus 5 cos x, okay, for all values of x is the same as, so it's equivalent to root 34 times sine of x plus 1.03, okay, and I'm going to give this to 3 significant figures and declare that I've done that. And of course I've got to double underline it, and now I'm done. Good.